Welcome to the Fiery proServer and Fiery XF 6.5 technical overview of the new Black Generation settings feature. This new feature was introduced in Fiery XF version 6.3 and updated in Fiery XF version 6.5. The new black controls provide you with a greatly expanded group of tools to set the Black Generation options when building ICC media profiles for EFI ViewTech, EFI Matan, EFI Reggiani, EFI Jetreon, and EFI wide format printers, the Epson SureColor 7000 and 9000 printers, the Mamaki TS300P-1800 printer, as well as the Roland TextArt printer and a number of printers in the Canon ImageProGraph Pro series. To access the advanced Black Generation tools, you will begin by printing and measuring your ICC profile target in the same way that you have in prior Fiery versions. After you finish measuring your profile target, you will come to the Apply Settings dialog box. At the top of the Profile Settings dialog box, you will find that there are default options available on the Settings drop-down list. Defaults will be selected automatically for printers that support the use of the advanced Black Generation tools. Another option is to select the Import Settings selection. If you do, you will be prompted to select an ICC profile that was built using your desired Black Generation settings. The settings used when creating that profile will be applied to your new profile. The presets available on the drop-down list have been optimized using the latest version of Color Profiler, Fiery XF, and the printer type that you have selected. If you decide to import the settings from another ICC media profile here, the settings from the version of Color Profiler that was used to generate that profile will be used. Now, this will not necessarily lead to bad results, but under certain circumstances, this may disable settings which would be needed to get the superior output quality available by using the latest version. Because of this, it is recommended that you start by selecting one of the presets available on the drop-down list and test the results. If you wish to modify either the default settings or your imported settings, click on the Edit Black Controls button. In the window that appears, you will see 4 tabs containing Black Generation and other important settings. Keep in mind that it is often best to use the default settings, produce a test print, and then decide if you want to make any changes to any of these settings. The first tab is the Black Controls tab, and the first setting is the Maximum Black Ink Control. This slider sets the maximum amount of black ink used at the darkest black point in the ICC profile that you are creating. Because black ink is limited by the calibration or .epl file, it is likely that you will always keep this setting at the maximum 100 limit. Next is the Black Start setting, which will determine where Fiery proServer or Fiery XF can begin to use black ink in your images. Black ink is important for a number of reasons, including improved printer stability and cost savings. However, small droplets of dark black ink in highlight and quarter tone areas can be noticeable. If you only have normal black ink available, selecting a higher level will keep these small dots of dark black ink out of highlights and quarter tones. Also, keep in mind that moving the slider to the right will increase your ink usage. If your printer utilizes light black ink, you may want to set the level lower, as the droplets of black ink will be lighter and less noticeable. Black Generation is sometimes referred to as GCR, which stands for Gray Component Replacement. Although not identical, the processes are similar in that they are calculations that are used to replace the neutral components of mixtures of cyan, magenta, and yellow ink with black ink, reducing your cost and improving gray stability. Let me illustrate. Imagine that this bar chart shows the amount of cyan, magenta, and yellow ink that makes up a single pixel in your image. Theoretically, there is a neutral component in this combination of inks. The cyan ink, along with an equal amount of magenta and yellow ink, will produce gray. As illustrated here, you could, again, theoretically remove all of the cyan ink along with an equal amount of magenta and yellow ink and replace this gray component with black ink, reducing the overall volume of ink because a smaller quantity of black ink can be used to match the density of the gray created by the cyan, magenta, and yellow inks. A better way to see this effect is shown in the center row, where I have stacked the ink volumes one on top of the other to better illustrate the ink volume reduction. The bottom row shows that ideally, the two different ink combinations will provide the same color result when the pixel is printed. Selecting a high level of black generation will replace the neutral component of each pixel at a more aggressive rate, while selecting a lower level will result in a more gradual neutral ink component replacement. The final option on the Black Controls tab is Black Width. This option defines where, within the gamut of your output device, the black generation function will be applied. When this slider is moved to the left, it limits the amount of black generation that you have set to neutral tones only. When moved to the right, you are extending black generation through non-neutral tones and eventually into more saturated colors, again decreasing your ink usage and cost. Next, we'll explore the settings available on the Advanced Black Controls tab. The first control that we have available is a setting for maximum total ink. Other than when dealing with a problematic output device, you will probably leave this slider set to the maximum value, as you will have set the total ink limit correctly when building the EPL file. Next up is the Ink Amounts at Black section. This section is used to define the ink combination that sets the darkest point of your ICC media profile. If you clear the Automatic Black Point Finder checkbox, the controls available are the same controls that you will see prior to the release of FireEXF 6.5. You can use these three sliders to limit the amount of cyan, magenta, and yellow ink used at the black point of the profile. This reduces your ink consumption, but may result in either a color shift in the darkest areas of your print, a loss of density in these areas, or both. As I mentioned earlier, it is best to use the default settings, produce a test print, and then decide if you want to make any changes. In the example shown, the black point of your profile would be defined as 100% black, selected on the Black Controls tab, plus 89% cyan, 89% magenta, and 100% yellow, selected on this tab. If you select the checkbox, the new controls introduced in FireEXF 6.5 become available. They help your Fiery system define the black point of your profile. You should note that you are not selecting the specific patch that will become the darkest point in your profile, as that may create some artifacts in your final prints. Rather, you are finding the point that Fiery will use to guide the complex math used to define the darkest point available in your ICC media profile. Finding the ideal black point is a balancing act between density and color balance. Let me illustrate. Here you can see two color samples. The one on the left is darker, but also has a greenish cast, while the sample on the right is lighter, but is neutral in color. Although it has been exaggerated here for presentation purposes, which would you want to use for your darkest attainable color? Depending upon the type of printing that you do, you may want to have a maximum density that is not neutral. This is often the case in textile printing. The Automatic Black Point Finder option controls the selection process. With this option selected, the Fiery Profiler will automatically select the darkest value from the target that you measured to use as the defined black point. The selection process is limited by the Search Radius control. You use this control to define how far away from the neutral axis you will allow the system to search for the darkest point. Moving the slider to the right will allow the system to search for the darkest measurement that may not be perfectly neutral. The window displays the amount of chroma that you are willing to accept in your darkest point. With the search radius set to 0, you are telling the system to only accept a value that is perfectly neutral. Now this could result in a maximum dark point that is lighter than might be available if you were to accept a non-neutral black. Let me illustrate. I have imported the IT8 measurement dataset that I will be using to generate my ICC media profile into the Inspect Profile tool of Color Profiler. This file will be found in the Measurements folder in the location shown here. In the display window, each of the patches that you measured on your profiling target will be displayed. Using the Rotate tool, I'll rotate the image upward until I see a side view of my data plot. Next, I'll use the Zoom tool along with the Rotate and Move tools as needed to zoom into the lower portion, which is where my darkest patches are located. The lower right-hand area will display the LAB values of any of these data points when I select them with the Select tool. In examining the plotted data points, if a data point is lower, it means that the patch that was measured was darker. The closer the data point is to the central axis line, the more neutral it may be. I use the term may be because we are only looking at one side of the data points plotted in three-dimensional color space. We would also need to rotate the plot 90 degrees to look at the other side view. It does, however, look like this data point is the darkest, and if I select it, we can see that it has an L star value of 10.02 and is indeed pretty dark. After selecting the other neighboring data points, I found that it is in fact the darkest. However, look at the A star and B star values. This patch, although it is certainly dark, is not at all neutral, but is instead a cooler purplish color. But if I decided that this is what I wanted to use as a guide when defining my black point, I would need to set the search radius to a value larger than the A star or B star value, whichever is larger. In this case, the A star value is the larger value at 6.06, so I would need to set the search radius to be larger and would likely set a value of 7. Let's examine some of the other data points. This data point is much more neutral but is also lighter. If I had the search radius set to a value of 2, the system might select this point as a guide when defining the black point in the media profile. Well, what about this point? It is a little darker, but look at the B star value. This patch was definitely more on the bluish side. Now this patch is one of the most neutral, but it is much lighter than the earlier patch we examined. But if the search radius was set to a value of 1, the system would use the lighter patch when calculating the maximum black point. Looking at the 3D plot from the top, we can get a better idea of the neutrality of the data points. Here is the point that we have just been examining, the one that is lighter. And here is the data point that is even more neutral, but is far, far too light to use when calculating the profile black point. As you can see, selecting the correct data point is definitely a process where you need to balance neutrality with density. Because most users will want the black to be close to neutral, it is suggested that you start by setting the search radius to 2 or 3, generate a profile, and evaluate the black point on some test prints. If the black areas look washed out or smoky, not really dark and rich, then increase the search radius setting to see if a more chromatic black, blacks that are not as neutral, are preferred. If you are looking to achieve the best possible black in your printed images while maintaining good shadow detail, you may want to try selecting relative colorimetric with black point compensation as your rendering intent on the color management pane in your Fiery proServer or Fiery XF. The results that black point compensation provides has been greatly improved recently. Note that you would likely never use black point compensation in a proofing workflow, as your printed proofs would probably not match the output from a conventional printing press. Returning to the advanced black controls, you can see the next new feature introduced with version 6.5, the Use Media Relative Colorimetry setting. Although we are talking about the black point of your profile, I'll use some much lighter examples here to help you understand what is happening. Now here we have two circles, one on a gray background and the other on a lighter reddish colored background. Depending upon your monitor, the circle on the right can look cooler, perhaps a little darker, but likely does not match the circle on the left, even though the circles are the same color. To correct for this, we would need to print the gray circle a bit warmer so that it would look neutral on the reddish paper. The color of the media is exaggerated here, but you will likely have seen this problem in your own printing, while the same visual problem can occur in the darker areas of your prints. The Use Media Relative Colorimetry feature helps address this problem automatically. One of the patches on the target you measured contains no ink. When measured, Fiery now knows the color and brightness of your media. With the Use Media Relative Colorimetry checkbox selected, Fiery will use this information to automatically add an offset or corrective value to the gray balance of the ICC media profile to help ensure that your neutrals look correct on this media, even though they would not measure as neutral. After you print and evaluate your sample images, you may want to fine-tune this adjustment. If you do, launch the Create Profile from Measurement tool in the Color Tools program and select your ICC media profile. Return to the Advanced Black Controls tab and, making sure that the Use Media Relative Colorimetry checkbox is still selected, enter your correction in the appropriate A* and B* fields and generate another profile to test. Another use for this feature is for a requirement often seen in the textile industry. Here, a customer has a sample of black fabric that measures with an A* value of 1 and a B* value of -4.5, and she needs the maximum black point to match the sample. In this situation, you would clear the Use Media Relative Colorimetry checkbox and enter the values obtained by measuring the swatch sample. With a search radius set to 2 or 3, Fiery will now look for the darkest patch available located within a radius of 2 chroma of your desired values. Again, you may need to test and modify these values to attain an acceptable match. The third tab in the Advanced Black Generation window is where you can set options used when the perceptual rendering intent is selected for use in a workflow in Fiery proServer or Fiery XF. None of the settings that you make on this tab will have any influence on images processed using either the colorimetric or the saturation rendering intents. The adjustments available on this tab allow you to modify the generation of images for a category we refer to as pleasing color, and would likely never be used to modify the ICC media profile used in a proofing workflow. The first option allows you to increase the chroma of your images. Modifying these settings is similar to adjusting the saturation of an image in Adobe Photoshop. The default setting is normal, where no change will occur, colorful, where a medium level of chroma boost will be applied, while the vivid selection will apply the highest level of chroma boost. You should note that this is an intelligent boost to the saturation of your images. Areas in your image with lower chroma or saturation values will be shielded from this adjustment to help prevent an unnatural look in your final image. The lightness slider allows you to adjust the lightness of printed files. The effect is similar to what would happen when you move the lightness slider in Adobe Photoshop. I've exaggerated the effect in this option to help you visualize the results. Immediately below the lightness slider is the contrast slider, used to increase or decrease the contrast of the output from your printer. Once again, I've exaggerated the effect of this option to help you visualize the results. The final option is the Shadow Lightness control. This control will allow you to lighten shadow areas of your images, but caution should be used as it is possible to produce slightly washed out shadows. The last tab is used to set additional processing options. The first option is used to add smoothing to your measurement data. You can use it if you suspect that your data contains noise and does not accurately reflect the characteristics of your output device. These measurement errors could be caused by instrument errors in your measurement device, banding on your output device, printer unevenness, inkjet head issues, or other problems. Of course, you should try to eliminate these errors before you print and measure your targets. A setting of 0 will allow you to create an ICC media profile using the most accurate measurement data, but that data will be the most subject to noise. While a setting of 1 will create an ICC profile using less accurate data when compared to your actual measurement data. However, it will also be less subject to noise. The 3 table smoothing sliders are used to add smoothing to the output side of your media profile. Here you will find separate controls for the perceptual, colorimetric, and, new in version 6.5, the saturation tables. The table smoothing adjustment controls the amount of smoothing on the output side of the ICC profile, which is the LAB to CMYK or B to A portion of the profile. Setting lower values on these sliders could result in higher single color accuracy, while using higher values could potentially lead to your printed results displaying smoother gradients. To test these settings, you could produce several profiles using different settings and print a set of sample images that include a file such as the Granger diagram. Check the images for an improvement in gradient smoothing and also for image artifacts. Another feature available for selection is the illuminant setting, which allows you to select the type of light source your prints will be viewed under in order to create more color accurate output. If you don't know what the final viewing conditions will be, leave this selection set to the default illuminant D50. Care must be taken with this option. Note that the same illuminant selection feature is also available near the bottom of the color management pane in Fiery proServer and Fiery XF. Although they basically produce the same results, they are intended to be used a little differently. Let me explain. Traditionally, we view the output from our devices under daylight conditions, often in a standard D50 graphic arts viewing booth. If we were to view our normally produced D50 output under incandescent or tungsten lighting, the output would take on a yellowish cast, exaggerated here for the purposes of illustration. If we were to shift the color of our output so that it printed with a blue cast, again exaggerated here, then that same output would appear to be more color accurate when viewed under our incandescent lighting conditions. The yellow incandescent light would offset the blue shift of our output. This is the purpose of selecting an alternate illuminant. It allows you to generate output that will appear to be more color accurate when viewed under the selected alternate illuminant. Make sure that you select an alternate illuminant only in one of these locations. The other should remain set to the D50 illuminant. Also, if you do change the illuminant settings when building your ICC media profile, it is recommended that you include it in the name of the profile to help avoid errors. We recommend that you select the alternate illuminant on the color management pane in Fiery XF when making the modifications on a per-job basis. We recommend that you select the alternate illuminant when creating an ICC media profile when you want to set up an output device where all jobs from all workflows connected to it will be affected by the change. And finally, you will find controls that can be used to modify the size of the input, perceptual, and colorimetric tables, as well as the output, perceptual, and colorimetric tables, and now, in 6.5, the saturation output table. Increasing the size of the tables may provide increased accuracy, especially in the reproduction of spot colors, but may also increase the time needed to produce color conversions. Most users will keep the default settings for these sliders. In testing, we have determined that there is no benefit in modifying the saturation input table size, and because of this, we have not included an option to modify that setting. This completes the technical overview of the new Black Generation Settings feature. You now have available a full set of tools that you can use to modify the final look and the ink usage of your output device. And remember, it's often best to use the default settings, produce a test print, and then decide if you want to make any changes to any of these options. Thank you for your time.